Firstly, we can sketch out graphs y equals fx and y equals gx so as to find the range of both graphs. So this is the range graph of y equals fx. The range will be all the values from negative infinity to infinity, however not including 0. And this is y equals gx graph. The range will be from 0 to infinity. Fg, the composite function fg does not exist since the range of g does not fall within the domain of f. However, composite function gf exists since range of f falls within domain of g is a subset of domain of g. For part 2, to find f inverse x, we firstly let y equals fx. So y equals to 1 over x minus 3. We need to make x a subject. So x minus 3 equals 1 over y, x equals 1 over y plus 3. So f inverse x equals to 1 over x plus 3. The domain of f inverse x is actually the range of y equals fx. The range of y equals fx, inclusive of all real values and not inclusive of 0. For part A, we will sketch on the Argand diagram locus of points representing a complex number z, such as z plus 2 minus 3I equals square root 13. However, we know the standard formula for this is z minus, so we change to the standard form, z minus negative 2 plus 3I equals square root 13. So you know negative 2 plus 3I is the center point and square root 13 is the radius. So firstly, we have to prove, okay, sum in z equals 0 to prove that negative 2 plus 3I equals square root 13. So as to prove that the curve passes through the axis, the center point is 0. So negative 2 by 3I is actually equals to square root 13. So this is the imaginary axis and the real axis. The negative 2 on the real axis and 3 on the imaginary axis is point. So since it passes through the center 0, therefore the radius will be square root 13. This is a circle. So part B is given that W star plus 2W equals 3 plus 4I. So we let W equals to x plus yi, and where W accelerates is actually equals to the conjugate of W. So W conjugate equals x minus 2y. So left hand side we sub in the values for W conjugate plus 2W plus x plus yi times x minus yi equals 2 times x plus yi. To expand, we get x squared minus y squared times negative 1 since I squared equals negative 1 plus 2x plus 2yi. Then we group them together in the real values and imaginary values. So x plus y squared plus 2x are the real values and 2yi is the imaginary value. So we know that on both sides they actually correspond where the real values equals to 3, x plus y squared plus 2x equals 3, and the imaginary value 2y equals to 4. So 2y equals 4, y equals 2. So we sub y equals 2 into x squared plus 2y plus x squared plus y squared plus 2x equals 3. X squared plus 2 squared plus 2x equals 3. X squared plus 2x plus 1 equals to 0. Using the calculator, x equals negative 1. Therefore, w equals to a, which is the real value, which is x equals negative 1, and b is actually the of which is y equals to 2. So w equals negative 2 plus negative 1 plus 2i.